Hello everyone and welcome to MS Auto Live. Today we are going to talk about Azure IoT and we have a very special guest, Pete Gallagher with us. Pete, welcome.
Hello.
So Pete, can you please tell me about yourself? You own a company and as far as I've seen your Twitter account, you own a community in the United Kingdom.
Yeah, so first and foremost, I'm a freelance programmer. So my company, PJG Creations, we work for a heap of different companies up and down the country, and some out of the country, in fact, mainly around IoT, but also in the entertainment and event space as well. So everything from programming and assembler all the way through Azure IoT to building WordPress websites, even pretty much anything that somebody will pay me to do, unless it's dancing in the rain. I probably wouldn't want to do that. I also run three different co-organise three different meetups in Nottingham in England, .NET Knots, Knots IoT and Knots Dev Workshop, and I'm involved with another meetup group closer to me called LATI, which is a high engineering business meetup. So that keeps me busy, as well as speaking around the country at other people's meetups on IoT topics as well.
Okay, thank you. Before we start our actual content, I want to ask you about the IoT term. It is not a new term. When I think it starts with M2M. And what is the difference between IoT and M2M?
So right, it did sort of kick off with M2M. Actually, I worked on an M2M machine-to-machine M2M, if you didn't know, a project way back in the late 90s. We made a Royal Mail stamp vending machine, and we were able to dial in over a modem, believe it or not, to be able to get audit logs and machine history traces and that sort of stuff. So that was just a small application running on a PC into an embedded processor that was able to then relay that. And that sort of shows what M2M is. It's often a bespoke connection between machines, and it tends to focus mainly on transmitting telemetry forwards and backwards, and in some cases like that, just from the machine to a central point. Whereas IoT, that tends to encompass, well, the cloud, the I part of IoT sort of gives away where the difference comes in. Rather than using proprietary communication protocols, you tend to use public ones that are easily accessible, and then you can build in all sorts of other functions on top of that telemetry, analytics and storage and things like that.
Okay, thank you. So which development languages should I know to code an IoT project? Because as far as I know, we are coding on a device, a hardware. Do I need to know low-level coding?
No, I mean, you can do it in assembly language if you really want to, but with .NET Core being open sourced and cross-platform now, you can leverage your C# skills if you like, and quite happily go away and program in C#, or you could do Node or C or Python or any of those different languages. Python is quite popular at the moment, but certainly people do program in C. If you're doing anything with Arduinos, then C is probably going to be your friend, but anything a little bit more powerful, like, well, even a Meadow, to be fair, in the Arduino space, that's C#. But a Raspberry Pi, for instance, you'll be able to do Node or C# for that too. So.
Okay, as you say, Raspberry Pi, and there is another platform called Arduino. What is the difference between Raspberry Pi and Arduino?
So an Arduino is a microcontroller-based platform. It's designed for sort of a low-cost, low-entry point facility for you to be able to do sensor telemetry and stuff like that. It doesn't have an operating system, and you're not usually connecting monitors and mice and keyboards to it. Whereas a Raspberry Pi, well, that's a full computer. In fact, I have one right here. You might be able to see. So inside that case, there's a Raspberry Pi 4, and that runs Linux. it's a Debian operating system, Raspbian, that I've got running on there, but it will run other operating systems. But that, yeah, it will work as a full computer. In fact, that Raspberry Pi 4 is pretty powerful. It's got dual 4K outputs and gigabit Ethernet and Wi-Fi and Bluetooth, and then all of the usual IoT bits and bobs, GPIO and serial interfaces and bits like that. So, yeah.
Okay, thank you. So you're an Azure MVP, and why do I need Azure for an IoT project? Or what services does Microsoft provide for us?
Yeah, well, I mean, as you said, I'm an Azure MVP, so I'm going to point you in that direction. It doesn't necessarily have to be Azure. Other cloud providers do exist, but I prefer Azure. I mean, the docs are what got me to Azure in the first place, because they're so good. The getting started tutorials and then the help along the way just seems more all-encompassing than what AWS give you, or Google, or IBM, or any of those, Oracle. But generally, depends on where you're going to start, but a lot of the services for IoT are going to start with Azure's IoT Hub, which is like a switchboard for IoT devices, and you can connect millions of IoT devices to a single IoT hub, and you can ingress all of the data from your devices that way. And then once they're in IoT Hub, then you can send those same messages then out into the rest of the Azure ecosystem and do what you like with them, stream analytics or to storage, or build off logic apps or web apps, or the world's your oyster. Once you've got it to IoT Hub, then you can connect it out to anything else.
Okay, thank you. Let's start then. Can you show us some cool stuff?
I can. Actually, I'm not going to start with Azure, funnily enough, although that is this first screen here. But what I find is that you don't always have to start with the I of IoT. Starting with the thing, I find, is the best idea. And there's a device called a microbit, which is not too far off from an Arduino that we mentioned earlier. And this is produced by the BBC. And you program it in many different ways, but Microsoft have produced an application called MakeCode, which is where we are here. And what's good about programs like this is that you don't actually need the physical device. So you come into MakeCode and you get a simulated microbit. So this has got a controller built into it, and it's got some LEDs and buttons, and it's got a gyroscope and a light sensor, and it's even got Bluetooth built in. And these are about a tenner in the real world, but you might not know what you want to do, and you might just want to have a play around with IoT devices rather than trying to connect things to the internet. So this is a great place to start, and it's really a device aimed at children, but it is pretty powerful actually. It's got the temperature sensor and a compass built into it, and you can drag that telemetry out via a serial port, which is through the USB port that it's got on it, to a more powerful device and do something with it. So you can utilize bits of it, but it's great for getting started, and you can drag bits onto this surface here. So if anybody's ever used Scratch, then this is very much like Scratch. So as soon as you do something on here on the left hand side, it appears, and you can drag buttons on there and make it do different things with the buttons as well. So we go ahead and hit the A button now, and we should get a heart. So am I not showing my screen yet? That would be bad.
No.
Yeah, so let's start that again. Look, there we are. So this is MakeCode. Just here, apologies, not sharing the screen. This is the microbit on the left hand side that I was just explaining to you, with people couldn't see before. And this surface on the right hand side allows you to drag blocks from this toolbox into patterns. So you can just make your application this way. And if you've not got very much experience with programming, this is a really good way of starting. But if you have got a little bit more experience, you can do all of that in JavaScript as well. And that's just converting that code in blocks there to JavaScript, and you can live in this JavaScript world if you like. You can have multiple of these on there, or you can control, if I go to the pins bit here, then we can control things like servos down here, servo right pin. It's easier to do that sort of stuff in the blocks, to be fair, if you're just getting started with it. So you can write a pin. As soon as you do that block on there, then underneath we get little servo. So this is where I point people when they're first getting started with IoT. And although it doesn't give you the eye of IoT, as I've just said, it does really get you started with how to connect things up. But you can use other simulators, and Microsoft have got quite a few of them. And we spoke about the Raspberry Pi earlier, and they have here, so this is on GitHub here, so it's just a free to use Raspberry Pi simulator that connects out to Azure. I mentioned earlier that Azure Iot Hubs is the place where you're really going to start with Azure. And I can give you a quick insight into how that works. If you come to the portal, so if you've used any Azure resources before, then you'll be free, well used to the portal. We can just go ahead and create resource. And in here, you can type in an IoT hub. It gives you some information on it, but as I explained, it's basically like a switchboard where all of your IoT devices are going to connect in together. You can select a subscription and a resource group. I'm going to create a new one just because I can tear this down afterwards. You shout if you can't see anything or if anything isn't particularly clear. I'm going to leave that in the East US for now, and I'm going to call it an MS How To Hub. And we can look at the size and scale. If you're just getting started, then there's actually a free tier here that allows you to send about 400,000 messages a day for nothing. Actually, it's 8,000 messages a day for nothing here, which is dead good. Does actually everything else that all of the other tiers do. Only the messages are 0.5K instead of 4K. So a message is just a block of information that your IoT device is going to send up. So some telemetry, some temperature information or something like that. And those messages for the free tier are maximum of 0.5K per message. So if you send a 1K message, that's going to use up 2 of your messages there. So I've already used one. You can only have one free tier, as it's saying there. So I'm going to create a standard tier on there. It comes with Azure Security Center as standard now, which just does some extra protection for your IoT hub, just to make sure that it's not going over some message frequencies that you're not expecting to get. You can change this if you like, if you're expecting to get more and more messages, but can you see the cost going up now? We don't want to be doing that, not for a demo. So yeah, £18 a month, and you can have 400,000 messages a month in that, a day rather, in that. So it's pretty capable. I think you'd be struggling to go over that for most demo projects. So we can create that. Happy. So this really will sit, it kind of sits at the edge of Azure. So if you imagine that you've got your devices that sit out in an office somewhere perhaps, and then you've got Azure as the cloud, you'd have IoT hubs providing an intermediary service between your device and the rest of Azure. So it's just a means of ingressing all of your data, and then you can process it somewhere else in Azure. So I've already created one of these earlier, so we don't have to sit and watch it create, because sometimes, especially with what's going on at the moment, things can take a little bit of a while. But this is what you'd get. You'd get your IoT hub and a menu down the left. And you have devices in your IoT hub, and I've already got a few devices in here. There we are. So I've created Raspberry Pi and then some other bits and bobs of devices. And we can go into these devices. And you don't get a massive amount of information in here, but what you do get is the way that you connect your code to the IoT hub. So if we flick back to this simulator, the only part of this simulator you really need to bother yourself with to begin with is this connection string across here. And that's got everything you need to be able to connect your device, the simulated device in this case, up into Azure. And you run that, which I'll do shortly, and then that'll send messages up to Azure. So we've not needed to buy a Raspberry Pi, we've not needed to install an operating system on the SD card and set that up, and then get Node installed and connect all of this lad up. They've done it for you, so it's really low barrier to entry stuff. So you run that, and we get messages going up. So that says that it sent a message up to IoT Hub. I can zoom in a little bit if it's more difficult for people to see. Bits and bobs going up there, but we can't really see anything. at the moment. It's going up, but we're just assuming that it's going up there. So you can use a tool called the Azure Iot Explorer. And I've already set that up for this particular device, and I can connect that to my IoT hub. And then that's given me my list of devices. And there's my Raspberry Pi that we saw from earlier. And that's that same information about the device identity. But down here on the left, we can see we have telemetry. And if I start watching that telemetry, then if everything's working, there we are. So there we have those same messages. So that's message ID 28 and device ID 29 and 28 are just there. So essentially what we've got there is this simulated Raspberry Pi is consuming this node code that's running there and sending that up to Azure IoT Hub, and then this IoT Explorer is then monitoring the messages on the IoT Hub and then just bringing them back down again. So that's like you've closed the loop there to a degree, as far as you just making sure that that whole loop is working correctly. You don't necessarily have to use this IoT Explorer. This is a download that you can get freely from Git. You can actually do all of this in VS Code as well. So there's a extension just here, which is I think it's the IoT Toolkit. Yeah, I'll post a link in the chat. I think it's called IoT Toolkit. Actually says there, IoT Tools Extension Pack. Ugh. Oh, I can spell extension. Why is it not appearing? Silly thing. Oh, there it is. Azure Iot. No. I'll post a link in the chat. I'm not quite sure why that's not appearing in there. But once you've got that downloaded, nonetheless, then at the bottom down here, then you get an Azure IoT Hub section, and once you've authenticated with Azure, which is the first thing that it'll ask you to do, then you get a very similar looking list of devices to what we had in Azure IoT Explorer. So if I just make sure that I've stopped my telemetry, which I have, then I can right click on this Raspberry Pi and we get some messages. We can generate some tokens in there, we can get some device info, or we can start monitoring the built-in event endpoint, which is exactly what we were doing in the IoT Explorer application. And there we are, there's those same messages coming down straight into code. So if you're developing your code directly in here in VS Code, then you don't need to be leaving. You can just do all of your workflow straight in VS Code, which is nice. So that's obviously giving you a Raspberry Pi example, but what they tend to demo at a lot of their workshops is this nice device. It's an MX chip device. So it's an Azure IoT developer kit, dev kit. And so they've produced this, got a nice little OLED screen on it and a couple of buttons. If you're paying attention earlier, when I did actually share the screen, it looks very similar to this microbit, doesn't it? And they've kind of gone for that so that they can utilize this edge connector type idea. But this is an Arduino based system, and you can program that in C generally, and you can do that in VS Code as well if you like, but this is an emulator or simulator for exactly that same thing. And similar to when we used the Raspberry Pi simulator and had to copy in the primary connection string, we can do that same thing here. We just paste in that primary connection string and we can run. And let's just make sure that we're looking at the right stuff here so we can clear that. And it's telling me to press the A button, and then we've got to shake it, which is always fun. And then it sends out a message. And if we return to here, then that message has gone from that simulator to IoT Hub as well, and then back down again to VS Code. And it doesn't tell us very much in there. It's just some demo code. It's actually looking at Twitter for a hashtag as well, which I can't really see the point, but I guess it's just proving that it can connect out to the rest of the internet there. So that's pretty cool. I like that. And they're the two main simulators that I tend to use when I'm talking about Azure, just because it's so fast to get started and you don't need to delve too much into the code. But when you do start coding, we mentioned earlier, you can do that in a plethora of different languages. But one of the ones I've been demonstrating recently is C#. So .NET Core you can get installed. It's not particularly straightforward to get .NET Core installed on a Raspberry Pi. If you've got a 64-bit, say Ubuntu or something, then there's a sudo apt-get for it, which is nice. But on a Raspberry Pi, it's a 32-bit ARM system, and there's no apt-get for the 32-bit binaries, sadly. So there's a whole heap of stuff. In fact, I've got a blog post. If I, where is it? Go to my website, shameless plug for a blog post. So all the way down here, on the next page, in fact, because it was a while ago now, and here. And if you go to this, and I'll paste that in the chat too in a minute, then this will take you through start to finish on how to do it. And I'm not going to go through it now, but this takes you through all the way through creating a console app and a Blazor app, so you can get both of those working on a Raspberry Pi. But yeah, it's not all that straightforward. There's binaries and linking and modifications to bash files and stuff like that to get going. But once you've done it, you only need to do it once, and you've got .NET Core installed on your Raspberry Pi. And I've already done that. And I've got some C# code here, which is hacky, just to make stuff work. But you can see there's nothing particularly fancy about it. There's the same connection string that I had there before. And then we create something called a device client. And I've got a message counter that I'm doing something with as well. We instantiate that device client with a connection string and then create a Gpio controller. So Gpio, general purpose input output, is all of the pins on your Raspberry Pi in this particular case that allow you to connect buttons and LEDs and servos and other more complicated bits of hardware to your IoT device. And C# comes with a Gpio controller once you've installed that npm package. So you've got all of that at your fingertips. I've wired up a button and an LED. I don't know if you're going to be able to see that. We won't, because I'm showing the screen, but I can show you the board in a little bit, but it's not particularly complicated. And what I'm doing is I'm just looping around here, and I'm waiting to see if any messages come from the IoT Hub. And if I press a button, then I'm going to send a message to the IoT Hub. And this code's living on my Surface Pro here, and I've got some tasks set up in this task.json to be able to, and I'm not going to go into too much detail, but there's a blog post on this too and a GitHub repository. But you can build and then deploy directly to a guest operating system like the Raspberry Pi. You've got to tell it to compile for ARM, of course. There's no good putting x86 stuff on an ARM processor. But once you've done that, then you can run your code directly from VS Code.
Pete, do you have other screen?
Can you not? Yes, hold on.
Asking about the screen.
Good point. Hold on, let me switch screens. Yeah, I forgot that Teams asks you to switch screens. One sec. Right, that might help a little bit. Can you see my screen?
We can see a
good. Yes, that's all right then. So I was explaining, and twice now I've done that, so apologies. We have a connection string and a device client here. And then this is all very hacky code, just demo code really. And we pass in our connection string to the device client. This is what's connecting us to Azure, this particular line there. And then this line is using an npm package to create a Gpio controller. And I'm just setting up some variables. I've got an LED connected to pin 10 on the Raspberry Pi, and I've got a button connected to pin 26 on the Raspberry Pi. And I'm then just opening those two pins, telling them that one's an output and one's an input. And then I've got a simple loop here that one part of it is waiting to see if a message comes from IoT Hub down to the Raspberry Pi. And then here I'm just reading a button, and if it's pressed, then I turn my LED on. And if I've not pressed it before, because it's going to be pressed so long as you keep it pressed. So I just once send a message up to IoT Hub, and those two routines are down here. So there's not much to it. We create a message on this line, and I add some properties to it if I've sent more than 5 messages, and then I send that message up. So the code's pretty simple here to send messages from a Raspberry Pi using C# up to IoT Hub. And likewise here, all I'm doing is awaiting this receive async method, the same device client I created earlier. And if a message has been received, then I just squirt it out to the console. And I can show that actually. So if I press my button that you can't see me pressing, but if I press it, then it says that it's sending a message up because the button's been pressed. And am I still? No, I don't think I'm still monitoring in here. Let's have a look, just make sure. Yes, I am. In fact, it says it there, you can see it. So I press the button and we get button pressed. So that's a message coming from the Raspberry Pi running in C# going up to IoT hubs, and then I'm monitoring for those messages, and I can then see them back here. Now, likewise, I can actually send a message, send a C2D message. That's a Cloud 2 device message, and I can say, hello, Raspberry Pi. And then all being well, if we go to my debug console, received message, hello Raspberry Pi. So that's a message from VS Code up to IoT Hub to the Raspberry Pi, and then I can see that back here in VS Code. So again, you're closing the loop on what you can do there, but now we have C# code able to communicate up to IoT Hub and then receive information back down from IoT Hub. So that could be something like a reset command, and in actual fact you'd use a direct command there rather than a message, but once you get onto that next step of using direct commands, then it could be a perform an update or reset yourself or turn the lights on or turn the lights off, or pretty much anything you want to do at that stage. But I mentioned earlier, once you've got it to IoT Hubs, then the world's your oyster and you can do practically anything you like at that point. And if I press my button a couple more times, if it's working, I think, let me just stop my code and restart it. I think I just broke it. Live code. So what these tasks are doing is compiling the code, and then I'm using something called rsync to determine what changes need to go down onto the Pi. So rather than sending every single file down, which can take a little while, it just sends the ones that have changed. So each time I run this, if it's been run before, this process is faster. And then it uses putty to be able to pull in a terminal session. So you can see that's what that's doing here. And putty, something called plink. It took me quite a while. There's actually an extension that promises to do this, but I couldn't get that working, which was a bit disappointing because it took me most of a weekend then to work out how to make all of this lot work. But the process is quite simple once you've got that working. So let's just see if that's working now. So sending a message, sending a message, sending a message, sending a message. So for, and then that message, theoretically, as it says, will trigger a tweet. So if I show you what I mean there, if I go back to my IoT Hub, then down here we can do something called message routing, and we can actually inspect the properties of the message and then send it somewhere else, like a service bus in this particular case. So just if I just, I know that I've not shared that screen yet, so don't worry. But you can see here my message count is greater than 5. I've added a property there called send tweet. So if I switch to, it's annoying, can't just switch screens while you're already presenting. So now you should see my IoT hub again. And in messaging, we have something called message routing. And I've already set up a few of these. And I've set up a tweet route. And if we go into that, then it goes off to an endpoint. And the endpoint is essentially what's going to connect it out to something called a service bus. If you've not used a service bus before, it's like a queuing system for messages. And so you can stick messages on there, and then other services can look at the contents of that service bus and grab the message off and then do something with it. I've got a routing query in here. So that's that send tweet that I mentioned earlier. And if it's true, so if I see a message on IoT Hub with that particular property, then I'm going to send it out to a service bus queue for something else to do something with it. So what I've done is created a logic app. So if I go to where my logic apps are, I've got one here called Send Tweets. And if you've not used logic apps before, these are sort of a block-driven primarily application. So it's a bit like an Azure function, but you're going to do this in blocks. And they're really good because there's a whole marketplace of functions that you can drag together and make your own business process up. So I've got one at the top here when a message is received in the queue. So if I see a message in that tweet queue that I created on the service bus, then we do some other things, post a tweet. And posting a tweet here is dead easy. Once you've dragged that particular, if I do this, look, we can add an action. I'm not going to save it, but I can type in Twitter here. And if I scroll down, then we have some Twitter stuff that you can do. And when you click on that, then it'll pop up the authentication tab, and you can just authenticate your Twitter account directly with this. It used to be that you had to create development accounts in Twitter and then share keys across and paste keys in, but now you can just authenticate directly with that. So once you've authenticated, then you get to stick some content in there. And I've just grabbed the content of the message, which is why that's saying content just there. And when it's run, so if I run this, and yes, it will take a few moments. So if I press my button, let's see if anything happens on the screen. I hope it will, unless my code has stopped, which it has. My buggy code. You've got to love buggy code for demos. You can tell it stopped because the LED just sticks on. So let's run that again. Oh, we've got enough time. It's not bad. Is there any questions in the chat there while we're waiting?
No, but I have a question for you. What are the other options like the Twitter? Can you show us some samples?
The other options of?
The logic apps. Do you understand Twitter?
Yeah.
And are there any options?
Yeah, I will do that just after this then, if you like. Let's just get that to run and then I can show you. As in, so not Twitter, in other words. So something else other than Twitter, do you mean? For logic apps. Good. Press the code. There we are, message, 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 message. And go back here, and hopefully this is running. Ah, good. Ah, that's what I wanted to see. It's good that it does it visually for you as well. So it's seen that message, and now it's complaining, actually, that it can't send a tweet. Forbidden. Oh, it's forbidden. That's probably because I added in that extra step earlier. So let's, in fact, I can show you that then. So let's delete that. Okay. So if you wanted to see what else is there, then let's see. There are a whole heap of things. So if we go to all, there. So we can book a new appointment on 10 to 8, whatever that is. We can get rows in Apache Impala. We can stop a web app, start a web app, create jobs. And this list, we're just on the A's there. Goes on and on and on and on and on. There's stuff for Azure Functions there, and there's stuff for Office 365 and Outlook. So deleting contacts, there's so many on there that it would take you all day just to figure out what they all do. It's obviously a little bit hard to get everything on the screen at the same time because there's so many. What else is on there? Look, creating CSV tables, inserting rows, creating a file in Dropbox even. So it's pretty powerful, the stuff that you can do with Logic Apps. If you've not played with them, I implore you to go and have a look. It's a really good way of just getting something done without needing to write the code. Obviously, the more complicated your business case is, then this isn't going to work. You're going to have to do something like Azure Functions after that. But for this demo, we were going to use Twitter. And I wanted to post a tweet. That's what I was hoping to do. I'm going to change this connection if it's complaining about that. Let's try this. Let's authorize it with that. See if I can break my work Twitter account live on Teams. So we can authorize the app. And then that should authorize. There we are, connected. And then we can add a parameter in there. And I'm going to say tweet text. Oh, hello, come back. And then I'm going to put the content of the message in there. And we don't need to add any parameters. So post a tweet, and the tweet text will be the content of my message. And then we can save that. And that was saved successfully. And let's run that again. Looks like my code is still running, amazingly. Well, it was until I pressed the button and then broke it again. I really should have spent more time debugging my own code. Did that answer your question on what else you can do with Logic Apps?
Yeah, thank you.
Good. Well, at least you're getting used to how this works, look. It's the most reliable part of this demo. So as I said earlier, I mean, Raspberry Pi is just what I tend to use for all of my demos, just because I don't have to program in C. But you could do the MX chip development directly in here as well. Good. Message, tweet, event. Oh, and now it's complaining about that as well. I'm not quite sure why it's complaining about that, but I did do this earlier. Tweet text, look, button press. So it got that far, but it's just complaining. I can't post the same tweet twice. Ah, that's why, you see. That's what it's complaining about. But I did one earlier and I deleted it. But you can send anything you like up to Twitter, and so this is the sort of stuff that I've been sending up in the past. Hello, if I then switch this off and then go back to my browser. See, I remembered to do it this time. Here. So there we are. So there's button pressed as what you would get if it wasn't the same message all over again. But this is some information from a lab that I wrote in Node, actually. that takes you through a lot of the stuff that I've just demonstrated, but in Node rather than C#. And you have a simulated temperature sensor on a Raspberry Pi, and you send that data, and the last step is logic apps that we've just done there, and that then posts out to Twitter. And yeah, that's just a demo of how you'd go out of IoT Hubs into something in the rest of Azure, and then do something a little bit fun with it, to be fair. I mentioned earlier MakeCode, and I like MakeCode because it's a good way to get started. But we mentioned Arduinos earlier as well, and this is a bit off topic. It's not exactly Azure, but I always like to demo this because this Tinkercad is fantastic. So if I sign into that, I like simulators. So this is made by a company called Autodesk, and I am sharing the right screen here, aren't I? Yeah, you can see what I'm doing on the screen. And there's something called circuits here, and you probably already spotted, look, we could drag Arduinos onto this, but this is a circuit playground essentially. So you can drag things like a battery and an LED on there, and we can hook them up like that, and then we can start the simulation, and there we are, we have an LED flashing. But it's quite clever in that, I don't know if you can see that, but it's actually telling me that the current through the LED is too high. That's why it's got that big ominous looking flash on it, and so it's clever enough that it knows that you need a resistor in there to make that work properly. I can start that simulation and we get a regular looking LED. But as I said earlier, we scroll down, go away, battery, scroll down here, and we have an Arduino, and you can drag an entire Arduino on there like that, and then you can hook up your Arduino. See if I can get this the right way around, and as soon as you drag an Arduino on there, you get an extra little button here called code, and see you have the same sort of Scratch-like interface, so block-based programming. And I like this because if you wanted to start with IoT and you weren't a programmer, trying to start with C is going to be a difficult place to start. That's probably the last place you want to go. But you can set pins in here, and I've got that connected to pin 7. And then we can put a delay in, and I can never remember which way around to connect this up to make it work, but oh, got that. So this is very similar to what I did in MakeCode, only now I'm doing it for an Arduino. And another wait, and we'll find out if I've wired my LED up the right way round. And no, so you can grab a hold of these and switch them around, in fact, or do that. Oop. No, run that again. There we are. Now we've got a flashing LED. You do any amount of IoT stuff, and there's always going to be an LED that's flashing. That's our hello world. But the great thing is that you can actually download that code as well, and it'll download it and convert it to C. And all you need to do is open it up in something like Arduino IDE and select your board and the COM ports, and you can program it straight into that same Arduino with that same wiring, and it will just work. So it's a really good way of getting you started without the worry of perhaps some smoke coming out of your Arduino that you didn't want to see. And there are a few other things as well. There's this Raspberry Pi Sense Hat, and so if you've heard about the AstroPi project, and if you haven't, essentially what that is Tim Peake, when he went up to the space station, he took 2 Raspberry Pis up with him that looked very much like this on the right hand side in a sturdy ruggedized case with this array of LEDs, and it's got a gyroscope and a magnetometer and some buttons and a temperature sensor. And the idea behind this was that kids can write Python code, in this case here in this simulator, and then they get sent up to the space station and run on one of these 2 AstroPi projects directly on the space station. That's a fantastic way if you wanted to introduce children and young adults to STEM subjects, to be able to tell them that their code could be running on the space station, running experiments on the space station is one sure way, because it's, you know, space is always cool, or at least I think space is always cool. So yeah, so I mean, I think I've run you through quite a few different options there. I don't know if you wanted to take some questions at this point, or see if you had anything you wanted to ask. I'll stop presenting for now, and then people might be able to see me.
Yes, if you have a question, can you see from Matt?
Let's have a look. Published. Matt, a client has data loggers that log sensor readings with a custom protocol over straight TCP/IP. Can I wire those in, and how? So, I mean, that would be a job for a Raspberry Pi, I would have thought, or obviously you can do it with a bespoke board, but if you're prototyping a Raspberry Pi would be ideal for that. I've got a similar project for a customer actually that uses Bluetooth sensors scattered around a building, and I've got a Raspberry Pi working as a gateway, which is essentially what you'd be doing there. So you'd have a gateway device of some sort that would collate all of that data and then send it up to IoT Hub and then do something else with it. IoT Hub, Microsoft's offering. And so yeah, that's it depends on what you're talking about there with the TCP/IP stack, and whether or not the Raspberry Pi would natively be able to understand that, or whether or not you'd need to write some low-level code to be able to interface directly to those TCP/IP devices. But if they're just standard network devices, you can just plug them into the network and then use whatever programming language you like to be able to interface into them, grab that data out, and then do something with it. If that doesn't answer your question, then do chime in. I don't see a response just yet.
Okay, I have a question for you.
Cool.
Okay, what are the challenges I may face in a big IoT project?
One of the problems is that, of course, a lot of this is going to be, well, there's several challenges, but one of them is that you're in the cloud quite a lot. So if things aren't working, it can be quite challenging to try and figure out why they're not working, because there's quite a lot of moving parts. Certainly, the more complicated the solution becomes and the more different resources you're relying on, then if things aren't quite working or something stops along the way, then you've got to make sure that you've got the requisite amount of logging in your system. I mean, I demonstrated just a few minutes ago with some quite simple code that whole thing just stopped working. It wasn't obvious actually that it stopped, and it was only really just because I was pressing a button that it wasn't working. Azure does give you quite a lot of facility for logging in there, and once you've got out of IoT Hub and you've got metrics, you've got metrics in and out of IoT Hub, as well as all the other services, then you can use those to diagnose some problems. Downwards from that, it depends on what you want to do, essentially. If you're working on something like a Raspberry Pi, then that's a relatively low barrier to entry, because it's an actual PC that you're working with. Going down further to something like the MX chip device and trying to get involved in C, which I'm no expert in C, although I did it quite a lot in the past. I tend to prefer C# these days. Even VB would be preferable to C. So yeah, getting started with something like that can be a difficult problem. Getting into the space, which is why I like the Raspberry Pi, because most people will either know Node or JavaScript of some sort, or C#. So that removes that problem there. Making a decision about what you want to do with your data and how you're going to process it can be quite complicated, because Azure is so large. There are ways to mitigate some of this as well. There's something called IoT Central, which I didn't show, which is a platform that you can spin up, and it sort of extrapolates a lot of this away. It's based on IoT Hubs, but you can create device templates in there. You've still got to write some code to connect to IoT Central, but what that allows you to do is get charts of your data or trigger alerts, or you can take that data out of IoT Central and then put it onto something like an event hub or into blob storage. But it sort of removes a lot of the need for creating all of the moving parts and hooking them together, because that's been done for you. There are other things you can do as well. If you don't like having to set Raspberry Pis up all day, you can do something called IoT Edge, which is essentially a Docker-based subsystem that you run on a Raspberry Pi or another operating system. And then you have individual modules that run in a container registry, and you can keep them up to date. And then that keeps your whole Raspberry Pi up to date, which leads into one of the other problems of dealing with anything in the field, is keeping stuff up to date. And yeah, running a Git clone and Git pull every now and again it works in a prototype, and I've used that. But if you want to do anything more production, then you really want to be doing it a little bit better than that. And IoT Edge will integrate with Azure DevOps and give you a nice CI/CD pipeline and stuff like that. Yeah, making decisions is probably the hardest part of all of this, actually. There's so many different ways you can go.
Thank you. Mert has responded, and he says they have their own hardware already that can only talk to an IPM port.
Yes, I mean, if you could talk to an IP, then a Raspberry Pi. So if it's a regular TCP/IP stack that you're talking about there and not something bespoke, then yeah, so long as it connects to a network, then yeah, you can poll out. Depends on what they're doing. If it's WebSockets or something like that, they can poll out to a port on that and communicate that way. It's going to depend on what interface after the network stack's there. You're really going to need to see what the requirements are at that point. It's difficult to know without actually seeing what it is or seeing the specs. But once you've got that data and that communication protocol working, then yeah, the world's your oyster at that point. Did I show you what you were expecting to see there? Did it make sense of the various different moving parts? Because I realised I went reasonably quick with that and didn't share my screen for some of it.
Okay, Mert, are you there?
He's gone off to do some port scanning. This was my, I mentioned it earlier, this is my Raspberry Pi, and that's the silly little circuit that I had running there. I don't know if it's still running. Oh, there it is. So I press the button and it does as much as, well, see, and that's what it was doing. It flashed the LED, and now it's not flashing the LED because it stopped. I'm not entirely sure why that is. I'll need to go and look at that. Hacky code, that's why it is. I need more try catches. Let me see if I can. There's a chat, isn't there? And I was going to paste in a link to. Oops. So this was the link to my blog if you wanted to get started with .NET Core 3 and a Raspberry Pi. Let's see if I can find that extension and why I can't see that. Yeah, and I went straight to it this time because nobody was watching. Yeah, Azure IoT Tools. Let's grab that. A shameless plug for our next talk, by the way, is I mentioned about integrating IoT Edge with Azure DevOps, and we'll delve into that a little bit more in that next talk.
Yes, I am very excited about it.
Yeah, it'll be good to talk about that, Will.
Yeah.
And we'll also look at Jenkins. I've got some revision to do actually, because that comes from a talk that I did before Christmas, so I need to make sure that all still works.
Yeah.
That should be the Azure IoT Tools extension for VS Code. Invaluable if you're going to do anything with Azure IoT Hubs. Well, VS Code, but I mean, why you're not using VS Code? Oh, good. Yeah, thanks, Matt. Matt says that for him, this is a good start and has got him thinking. No worries at all. I have, let me see if I can get my Node lab as well. Interested in that. And to tell you what I can also do is post in simulators. Flicking between Q&A and the chat. So that's the Raspberry Pi simulator I've just posted the link in the chat for. I'm assuming that other people can see this chat. Certainly.
Can you post on live event Q&A?
Probably. Let me do that. Make an announcement, I guess.
Yeah.
So let's do these. So running a VM. Matt says running a VM in IoT Hub. Yeah, and you can certainly do that. Raspberry Pis are quite happily running Docker, quite good at it. Certainly this Raspberry Pi 4 is very good at that. And that's what Azure IoT Edge is basing itself off of, is containers. And you have lots of little containers and they talk to each other through a communication pipe. And then that goes back up to an IoT hub still. And then you've got a container registry full of these little modules. So you'd have one that does temperature sensing and one that does some form of cognitive services and one that's got a SQL database in it, for instance. And so you try and keep these distinct little modules separate so that it keeps your code simple and more maintainable. And then you can run all of that through Azure DevOps, as I say, and build those container images for when somebody checks in a code change to a repo, which hopefully we'll be able to demo some of next week. What is it? Tuesday next week, is it?
Yeah, Tuesday.
Yes. So that's one. This is the VS Code extension. Let's do another one. Raspberry Pi simulator and the DevKit simulators. So I'd recommend starting with one of those two and just go ahead and have a play and see what you can make it do. If you want to get in touch with me on Twitter, then I'm at Pete_codes on Twitter. You can just send me a tweet and I will endeavour to help you as much as I possibly can. I've got a whole heap of blog posts on my Pete Codes website as well that I mentioned earlier, but if you go there, then there's stuff there about getting Raspberry Pi set up to do IoT Edge and DevOps. I've not finished writing that series, but there's already 7 blog posts, I think, so that'll keep enough people going for now.
And Pete, with your permission, I am going to put this session on YouTube.
Cool.
In a few days.
Yeah. See if we can cut out the fact that I'm not sharing my screen.
Okay. Okay.
Oh, there's a new question. Oh no. Yeah, no, that's the same.
Let me share our site.
Yeah, Van Cat earlier was asking if I could share the links. So yeah, that should be pretty much you like. Yes, Cloud Family, absolutely. So does anybody else have any questions just before we finish up? I think we're finish up on the hour, don't we, at 6 o'clock my time?
Yeah, I think that's all.
Well, fair. Well, thank you very much for having me along.
Okay.
It's been good. Yeah, apologies for the screen sharing not quite working, but yeah, that's what happens. and yeah, and my frail code, my frail demo code. But yeah, I hope it made sense to everybody. I know it was kind of a flash through, and we didn't cover absolutely everything, but hopefully it gave you a taste of what's there and how easy it is to get started, really.
Thank you very much, Pete. It was a fantastic session.
Thank you.
I think it was very educational.
Good stuff. All right. Well, yeah, thanks very much for having me.
Okay. Thank you everyone for joining us today, and see you our next session. Bye.
Cheers.